just give you an example of analysis of variance. Let's see if this works for us. And this is going to be really just a quick illustration of how you might do an analysis like this in SPSS. This kind of thing would be a little bit complicated, a little bit tedious to do in Excel. So you would almost certainly use something like SPSS instead. See if I pick a good data set out. Okay, here we go. I'm going to look at the variables first. There's two variables here. The first variable is called group. The second variable is IQ. So this is the results of an IQ test. If I look at the group variable, I can see that, it says scalar, but you want to know something. Look, it says it has different values, like 1 represents physics students, 2 represents math students, 3 represents chemistry students. So that is not a scalar variable. That's a nominal variable or categorical variable. That's a nominal variable. So what I just did there was check to make sure SPSS interpreted it correctly. But that is a nominal variable. So I have a nominal variable and a categorical variable. Categories and numbers, right? So I'm going to take a look at the data itself. And this is what the data looks like. Actually, to tell you the truth, if the actual data, if I go here and turn off value labels, the actual data is 1, 2, and 3 represents whether it's a physics student, a math student, a chemistry student, and so on and so forth. But we've identified that for SPSS in the variable page, in the variable window, right? So we've told it that 1 represents this kind of student, 2 represents physics, 2 represents math, 3 represents chemistry. So I'm going to go back here. So our two sets of data, two variables are group, which is categorical, and IQ, which is numerical. So how would we compare these groups? Well, if it's an IQ test, it's numerical, it's a score. So we might say, let's find the average score in our samples for physics majors and the average score for chemistry majors, the average score for math majors, and compare those. If we only wanted to compare physics and chemistry students, what test would I use for this? I'd use a t-test, right? Everybody agree with me on that? We use a t-test because that's what you use to compare the means of 2 groups, physics and chemistry. But now we have 3 groups, physics, chemistry students, and math students, right? So in order to use a t-test, I have to compare physics and math students, physics and chemistry students, math and chemistry. I have to do a t-test 3 times. But I want to do that because it increases my error each time that I run a t-test. So I need another test that I can do that compares more than 2 groups at the same time, more than 2 samples at the same time, where a mean is concerned. And that's going to be analysis of variance. So I'm going to go up here. I'm going to analyze. And I'm going to go to, let's see, compare means, because we are still comparing means. And I'm going to go down here to one-way analysis of variance. Next week, when you watch the videos I put up, it will explain to you why analysis of variance is called analysis of variance when what you're really doing is comparing means. Right? It'll make sense to you, I think. I hope. Okay, so I'm going to go in here, and it asks me for 2 things. The dependence list, that's usually what you're finding the mean of or doing the calculation on. So that's going to be our academic performance score, our IQ. I'm going to put IQ into there. And then it's going to ask me, it asks me down here for factor. Factor means, like in math, when you factor something, you break it up into different groups, different numbers. When you factor 36, you say to yourself, okay, 12 times 3, and 12 can be broken up into 4 and 3, so it's 4 times 3 times. So you break it up. So factor, in this case, means break up the data into the 3 groups, physics, math, and chemistry students, and examine them individually, right? So I'm going to tell it, I want to factor it according to the group. I'm going to highlight group and put it into the factor. Okay, so there's something in here, it's called posthoc. I'm not going to do anything with that right now. Posthoc means after, in Latin, it means after the fact, basically. Right, so I'm just going to go ahead and I'm going to go ahead and run this analysis. And it's going to calculate a statistics called F statistics. It's going to be an F. A statistic for analysis of variance. And if I go down here, here it is. It does this. It does the calculation. Here's our table. Table will mean more to you next week than it does today. The important part is the statistic, analysis of variance statistic, is 20.016. We have a table we can go to. That table will tell us for this number of variables, what does your, and this number of degrees of freedom, what number does that have to be in order for you to reject the null hypothesis? What do you think the null hypothesis is here? Null hypothesis for a t-test is mu for chemistry students is equal to mu for physics students. And the alternative would be mu for chemistry students does not equal mu for, I forget which one I said, physics students, whichever one the other one is, right? So if we're only doing two, that's what it would look like. What do you think it would look like, the null and alternative hypothesis for three groups for analysis of variance? I know you're not asleep yet, it's still early, like this light outside. Somebody take a guess. Mu for chemistry is equal to mu for physics is equal to mu for math. All the means are the same, right? That's your null hypothesis for analysis of variance. What's your alternative hypothesis? Well, you know, it gets a little tricky. You might say to yourself, they're all different. But you know, we're looking, we don't know if they're all different or not. So our alternative hypothesis is going to be at least two of the means are different, right? So our null hypothesis, they're all the same. Our alternative hypothesis, at least two of the means are different. In order to reject the null hypothesis, we have to have a value of F that's big enough that it won't show up more than 5% of the time if it's not true. Right? So we need that number F to be large. Well, there's a table that'll tell us what that critical value of F has to be based on the number of categories, sample sizes, and so on and so forth. But for our purposes with SPSS, we don't have to do that because it will give us the probability under significance, under SIG. So what's the probability you would be wrong if you reject the null hypothesis here? It's less than 0.1%, right? So since it's less than 0.05, we can reject the null hypothesis, and we know at least two of these means are different. At this point, we don't know which two, right? So that's why we go back to analyze, and we go into compare means and back to analysis of variance. And this time we go into post-hoc tests. And these post-hoc tests you run only if you can reject your null hypothesis. That's this case. So now I need to know which of the means, which of these comparisons are indeed different, right? So let's see, what am I going to use here? Well, there's a number of them. There's two that are the most popular, Bonferroni and Tukey. There's different styles of tests. I'm just going to pick off Bonferroni. That happens to be a relatively conservative one. I'm going to say continue. So now, in addition to doing the analysis of variance again, it's now going to do another test. And in this test, it actually compares each individual pairing, right? Physics student versus math student, physics student versus chemistry students. And there we can look for the significance of individual tests. So can we say that physics students and math students are different? The mean for physics and math students are different. No, we can't, because the significance is not less than 0.05. How about physics students versus chemistry students? Yes, we can reject that null hypothesis. How about math students versus chemistry students? Well, yeah, you can reject that also. That's also 0. And this is just a retread, chemistry and physics, chemistry and math. So both of those are different than chemistry students, right? But you can't say that physics students are different than math students. So we can see which means are statistically different and which ones we can't say are statistically different. So apparently, we can't say that the mean for physics students and math students is different, but we can say that the means for math and physics, math and chemistry students, those are different. Okay. So it's done this analysis for us, and it's done it without giving us any extra inaccuracy, any extra chance of rejecting the null hypothesis inappropriately, like we would have if we had to run the t-test 3 times in a row. Okay, that's how we use analysis of variance. So where would you use this data? use this data where you have groups, and each one of the people in those groups, you have a numerical value for it. Could be BMI, could be weight, could be blood pressure, could be blood sugar, right? Whatever that number is, where you want to compare the means of different groups to one another, right? Say mean of group 1 is equal to mean of group 2, mean of group 3, mean of group 4. Or it's not, at least 2 of them are different. Right? Those are a null and alternative hypothesis. Okay, not that hard, right? Especially using SPSS. And if you interpret the data correctly, use your data correctly. And we're going to get to the point where we're going to play around with this. Okay, so what I'm going to do now, I'm going to put this away. Remember, we're really going to go into this in detail next week. But I wanted to expose this to you because what if you went into the data and said, gee, I got really good information on age. I have all these 8,000 people. I got their ages, right? And I got I have their, we're going to think of that might be the appropriate age. I have their ages and I have their blood pressures. But maybe not blood pressure, that's numerical. I have their ages, which is numerical, and I have their ethnicity, right? And so I wanted to know in New York City, are different ethnic groups, the average age of different ethnic groups, are they different, right? So gee, I have like 7, maybe in the data, you have 8 different ethnic groups. And for each of the 8,000 people that are in different ethnic groups, you have ages for all of those 8,000 people. And you want to know is the average age for group A different from group B, group C, group D, right? So that's the kind of situation where you would use this statistic. So if that's what you choose to do, this is the statistical test that you would use.